Hello my friends and welcome to my channel. Walter here, and today we are going to be working on a Pure Maths 1 paper, that's paper 12 from the October-November 2023 sitting. Now without much further ado, let's get right into the paper. We're starting with question number 1. It says, the coefficient of x cubed in the expansion of 3 plus 2ax to the 5 is 6 times the coefficient of x squared in the expansion of 2 plus ax to the 6. Find the value of the constant a. Alright. Okay, so here we are considering two terms. And let's start by considering the term in x cubed. So I'll say here the term in x cubed. Okay. When we find the term in x cubed, we are going to consider its coefficient, which they have told us that it is 6 times the coefficient of the term in x squared. Okay, so for the term in x cubed, write in the expansion of this binomial. If we go to the list of formulas and scroll down to binomial series, we can make use of this binomial expansion to help us find the terms in the expansion for this particular problem. So here I'm saying that we are making use of this. Okay, let me just put it up here. So considering 3 plus 2ax to be in the form a plus b, and that's to the power n, where n in this case is 5, we can say that to get a term in x cubed, it has to be a term that is such that the b, which is this part, is raised to the power 3. And I think you can see that we have a b to the power 3 on this fourth term in the expansion. So we are considering n choose 3, and n is 5 for us, so it's like 5 choose 3 of a to the n minus 3. A is 3, so that's 3 to the 5 minus 3, that's a 2, and that's of b, which is 2ax, and that's b to the power 3, so 2ax cubed. So this is what's going to give us the term in x cubed. So we can simplify this using the calculator. So here I'll say 5 choose 3 times 3 squared, which is 9. Then that's times 2 cubed, which is 8. And we get 720. So it's 720 a cubed x cubed that we get. Next up, let's consider the term in x squared. So for the term in x squared, and in this case, we are considering the binomial 2 plus ax to the 6. So if we say that this is a and this is b, for a plus b to the n, in order for us to get a term in x squared, the ax has to be squared. That is, the b has to be squared. And we can see that this is possible on this term here. That's where b is squared, right? So that's n choose 2, where in this particular case that's going to be 6 choose 2, and it's a to the n minus 2. A is 2, so that's 2 to the n minus 2, which is 6 minus 2, so that's 4, and that's of b squared, which is ax squared, so that's ax o squared, and that's going to give us, let's simplify this. So we're saying that 6 choose 2, and that's 2 to the power 4, which is 16. So we will get 240 here. So it's 240 a squared x squared. So according to the question, the coefficient of x cubed is 6 times the coefficient of x squared. That means to us that 720 a cubed is equal to 6 times 240 a squared. All right, so we can bring everything to one side. So it's basically 720 a cubed minus 6 times 240 is 1440 a squared, and that's equal to 0. I'll factor out here 720 a squared, which will give us here a, and here that will be 2. Okay, and that's all equal to 0. So it's either 720 a squared is the one that's equal to 0, or a minus 2 is the one that's equal to 0, such that here we'll get a to be 0 and here we'll get a to be 2. Okay, so obviously a cannot be 0, so the value of a we'll get here is 2. So that's how we do it for this particular question right here. So let's move on to question number 2. On number 2, the question says, find the exact solution of the equation as 6 pi plus arctan of 4x equals to minus arc cos of half root 3. Alright, so here we have a 6th pi and it's plus arctan of 4x, and that's equal to minus of arc cos of half root 3. Now we know that arc cos of half root 3 is 30 degrees, which is pi over 6, so it's as good as minus pi over 6. And if we take a 6th pi to the right hand side, that's arctan of 4x is equal to minus pi over 6, which is 6th pi, in other words, and the 6th pi, when it crosses over, it becomes minus a 6th pi again. So it's as good as we have arctan of 4x being equal to minus a 6th pi minus a 6th pi, which is minus a 3rd pi. Right, so to get 4x, we can get that by saying tan of minus a 3rd pi. Alright, so for tan of negative a 3rd pi, we can simply use our calculator. So tan of minus a 3rd pi, which is like pi over 3, and here we get minus root 3. Alright, so 4x is equal to minus root 3, and dividing both sides by 4, we get x to be minus root 3 over 4. So basically this is the answer to question number 2, and that's how we do it right here. Let's go on to the next question. So now we are on number 3. It says the equation of a curve is such that dy by dx is half x plus 72 over x to the 4. The curve passes through the point 2, 8. So on A, find the equation of the normal to the curve at P. Alright, so they want us to find the equation of the normal. And for us to find the equation of the normal, we need to know what the gradient of the normal is. Alright, so let's start with finding the gradient of tangent of the tangent. Alright, which will be dy by dx, and x having a value of 2, so that will be half of 2 plus 72 of 2 raised to the power 4. Alright, so basically this will be half of 2, that's 1, and it's plus 72 over 16. Alright, so that's 72 over 16. Alright, we can reduce 72 over 16 to lowest terms by dividing by 8. If we divide by 8, 8 goes into this 9 times, and 8 goes into this 2 times, right? So it's as good as we have 9 over 2. So 1 plus 9 over 2 is 11 over 2. Alright, so we can now get the gradient of the normal, alright, which is like the negative reciprocal of 11 over 2, so that's minus 2 over 11. And therefore, we can find the equation of the normal now. And for the equation of the normal, we can say y minus y1, which is 8 in this case, is equal to minus 2 over 11 of x minus 2, like this. So that's y is equal to minus 2 over 11 of x, and when we multiply minus 2 over 11 by minus 2, that will be plus 4 over 11, alright, and plus 8, okay. So the final answer will be y is equal to minus 2 over 11 of x, and for 4 over 11 plus 8, we get 92 over 11, so it's plus 92 over 11. So what we have right now is the equation of the normal to the curve. Alright, let's go on to part B. Now in part B they say find the equation of the curve. Find the equation of the curve. So we have been given dy by dx right here. So we have the dy by dx. So I'm gonna place it here. So this is what we've been given for dy by dx, which means that to get y, we will integrate it. So that's the integral of half x plus 72 of x to the minus 4 with respect to x. So that is going to give us y being, integrating this, we get a quarter of x squared, and integrating this, we will be having here plus 72 of x to the minus 4 plus 1, which is minus 3, and it's over minus 3, and it's plus c. So this is y is equal to a quarter x squared, and this becomes minus 24 over x cubed plus c. Now we can find the value of c using the fact that the curve should pass through the point 2, 8. All right, point P with coordinates 2, 8. So when we consider the point 2, 8, all right, we know that when x is 2, y is 8, so 8 is equal to a quarter of 2 squared minus 24 of 2 cubed plus c, which is 8 is equal to a quarter of 4, that's 1, and 24 over 2 cubed, which is 8, is 3 plus c. So 1 minus 3 is minus 2, and if we cross it over, it becomes 10. So c is 10, that's c. So basically we are saying, therefore, the equation of the curve, okay, equation of the curve should be y is equal to a quarter of x squared minus 24 over x cubed plus 10. So basically that's how we do it for this particular question right here. All right, and that's how we do it. Let's go on to the next question. Now we are on question number 4. It says the diagram shows the shape of a coin. The three arcs A, B, BC, and CA are parts of circles with centers CA and B respectively. ABC is an equilateral triangle with sides of length 2 centimeters. So on A, find the perimeter of the coin. Right. So we can see that ABC is an equilateral triangle with sides of length 2 centimeters. So we can actually complete triangle ABC, as they say. All right, triangle ABC here, maybe like this. All right, and this makes an equilateral triangle, which means this side is a 2 centimeter side, and the 2 centimeter side, and this one is a 2 centimeter side. And it's apparent that if this triangle is an equilateral triangle, then all the angles should be a third pi, right? So pi over 3, pi over 3, and pi over 3. And it's also apparent that with the situation here, it means the arcs AC, AB, and BC are actually equal. So to get the perimeter of the coin, which is the distance right round, we'll be saying the perimeter is going to be 3 times the length of a single arc. So let's find the length of a single arc. All right, the length of arc is r theta. R is like a radius, right? So let's just consider, say for example, the arc AB. The center would be C according to what they have told us, and the radius will be a 2. All right, so r theta would be 2 times pi over 3, or a third pi. All right, so the 3's cancel here. All right, goes in once, and we get P to be 2 pi. So that's basically how we do it for part A. Let's go on to the next part. On part B, they say, find the area of the face ABC of the coin, giving the answer in terms of pi and root 3. All right, so they want us to find the area of the face ABC. All right, now this whole shape here can be considered to be made up of 3 segments. All right, so we have 3 equal segments. So this is a segment, this here, and this here is a segment. So we actually have 3 segments and an equilateral triangle at the middle. So we shall need to find those areas and combine them. All right, so let's do that. All right, so for the total area, it will be 3 times the area of a segment plus area of the triangle. Now the formula for area of a segment is area of a segment is equal to half r squared theta minus sine theta. All right, that's what we're going to be using here. So basically it's 3 times half r squared, the radius is 2. All right, so it's half of 2 squared, and we are saying of theta, which is pi over 3 or a third pi, minus sine of a third pi, and it's plus the area of the triangle. The triangle is an equilateral triangle, and we can use half side times side, sine of included angle, so it's half AB, which is half 2 times 2 of sine of pi over 3. All right, that's the area of the triangle. All right, so let's simplify what we got. So this is 3 times, actually this is 3 times half times 2 squared, which happens to be 2. So basically here we should be having a 6 of pi over 3 minus sine of a third pi, or sine of a pi over 3 is like sine of 60, which is root 3 over 2. So we have root 3 over 2 here, and it's plus here we get 2 of sine of this, which is 2 of root 3 over 2. All right, so basically that's what we'll be having. So the 2's cancel here. All right, and 6 times pi over 3 is 2 pi. 6 times minus root 3 over 2 is minus 3 root 3, and is plus root 3 here. So basically we'll be having 2 pi, and minus 3 root 3 plus root 3 is minus 2 root 3. So this is the answer we get right here. This is how we do it. All right, let's move on to the next question. That is question number 5. It says the first, second, and third terms of a geometric progression are sine theta, cos theta, and 2 minus sine theta respectively, where theta radians is an acute angle. So in part A, find the value of theta. All right, so we've been given that sine theta, cos theta, and 2 minus sine theta are first, second, and third terms. All right, so this is a first term, this is a second term, and this is the third term of a GP. All right, and they want us to find the value of theta. So we know that if we say cos theta over sine theta, this should be equal to 2 minus sine theta over cos theta, because this over this gives us r, and this over this gives us r. So these two should be the same, and from here we can cross multiply. So if we cross multiply, we'll be having cos squared theta being equal to sine theta of 2 minus sine theta. So that's like cos squared theta is equal to 2 sine theta minus sine squared theta. All right, so we're going to express cos squared theta in terms of sine theta. So that's 1 minus sine squared theta is equal to 2 sine theta minus sine squared theta. Here we can see that the minus sine squared theta is appearing on both sides and the same, so we can subtract it from both sides, so that eventually we'll be having 1 minus 2 sine theta remaining, and this is equal to 0. All right, so sine theta is equal to, if we make sine theta the subject, is a half, all right? And to get theta, we'll say arcsine of a half, and the value we get from arcsine of a half is 30 degrees, all right? And that's the only acute angle that we can make use of, all right? So it has to be pi over 6. So that's what we get right here. Let's go on to part B. All right, now on part B, they say, using this value of theta, find the sum of the first 10 terms of the progression. Give the answer in the form b over root c minus 1, where b and c are integers to be found. Right, so they are saying that we should use this value of theta. So the first term, according to the information they gave us right above, okay, let me just make use of this information. So they have given us these 3 terms, which are the first 3 terms in of the GP. So we know that the first term, A, is sine of theta, and theta has the value of pi over 6, or a 6th pi. So it's sine of pi over 6, and we know that sine of pi over 6 is a half. The second term, which is our AR, is cos theta, which is cos of pi over 6, and we know that this is root 3 over 2. So therefore we can find R by saying root 3 over 2 divided by a half. You know how if we divide AR by A, we get R. So that's why we have that. All right, and we get R to be root 3. All right, so we now have A and R. So we can now find the sum of the first 10 terms of the progression. So that's sum to 10, and it's equal to, we know that R is greater than 1. So we're going to use the formula A, which in this case is a half, of root 3 to the power of n, which is 10 minus 1. And that's over here. That will be root 3 minus 1. So root 3 minus 1 right here. So this gives us half of, and root 3 raised to the power 10 will give us 243. So we have 243 here, and it's minus 1, and it's over root 3 minus 1. So basically we have half of 242, which is 121, and it's over root 3 minus 1. So this is the answer right here. That's what we get. All right, let's move on to the next question, which happens to be number 6. It says the equation of a curve is y is equal to x squared minus 8x plus 5. So on A, find the coordinates of the minimum point of the curve. All right, so we want the coordinates of the minimum point, and we know that at the minimum point, we know that dy by dx is equal to 0. So we are going to find dy by dx here, which is 2x minus 8, and we equate it to 0. And solving for x, we get x to be 4. So we have x being 4 right here. All right, so when x is 4, we can now find the value of y. So y will be 4 squared minus 8 of 4 plus 5, and that's 16 minus 32 plus 5, and that is minus 11. So therefore the coordinates of the minimum point will be 4 and minus 11. So that's how we do it for this particular question right here. All right, let's move on to the next one. Now on the next part, it says the curve is stretched by a factor of 2 parallel to the y-axis, and then translated by 4 and 1. So on B, find the coordinates of the minimum point of the transformed curve. Alright, so here I'm going to consider the equation of the curve, all right, and I'm going to paste it down here. So here it is, and I'm going to write it in completed square form. So basically this is the same as y is equal to, and completing the square, that's x minus 4 squared minus 4 squared plus 5. So basically I'll say let f of x be equal to the x minus 4 squared, and minus 4 squared plus 5 is minus 16 plus 5, which is minus 11. So this is the first transformation, which is a stretch by factor 2 parallel to the y-axis. So applying that first transformation, I'll call that transformation number 1. It will give us 2 of f of x, which is 2 of x minus 4 squared minus 22. Okay, and I'll say that is fine, and I'm actually going to call this g of x. All right, and the second transformation are the translations. So number 2, we are performing these translations on what we got here, which I'm now calling g of x. So in terms of g of x, it will be g of x minus 4. Okay, so minus 4. If it's a positive 4, then inside the bracket in function notation it will be negative, and the 1 is a plus 1, so plus 1 here. So basically these are the transformations. So we are performing them on the above, which will be 2 of x minus 4, and there's another minus 4 here, and close bracket squared, and it's minus 22, which was already there, but there's a plus 1, so I'll say here plus 1. So I've performed the x translation and the y translation here. So basically the final result will be the transformed curve is y is equal to 2 of x minus 8 squared, and minus 22 plus 1 is minus 21. And we can actually derive the coordinates of the turning point, that is the minimum point, from the completed square form as being negative of minus 8, which is 8, and the number outside minus 21. And this should be the answer to part B. Let's go on to the next part, which is part C. It says, find the equation of the transformed curve, giving your answer in the form y is equal to ax squared plus bx plus c, where a, b, and c are integers to be found. Right. So we're going to go back, and you can see here that the transformed curve, we actually had obtained it to be this. All right. So here, if we take that equation, we can simply expand it so that it's in this form. So that will be y is equal to 2 of expanding this, that's x squared minus 16x plus 64, and it's minus 21. So that's y is equal to 2x squared minus 32x plus 128, and it's minus 21. So that's y is equal to 2x squared minus 32x, and it's plus 107. So that's the equation we get, and that's how we do it. So the job, we'd already done most of the job in part B. Let's move on to the next question, which is number 7. On number 7, the question says on part A, verify the identity 2x minus 1 of 4x squared plus 2x minus 1 is identical to 8x cubed minus 4x plus 1. All right. So let's use the left-hand side, where we have 2x minus 1 of 4x squared plus 2x minus 1. This is the same as 2x of 4x squared plus 2x minus 1, and minus 1 of 4x squared plus 2x minus 1, which is 8x cubed plus 4x squared minus 2x. This is minus 4x squared minus 2x plus 1. So the term in x cubed is 8x cubed. 4x squared minus 4x squared is 0. Minus 2x is minus 4x. And there's a plus 1 there. And this is what we get. And you can actually see that it's equal to the right hand side. So therefore verified. Let's go on to part B. On part B, the question says, prove the identity that tan squared theta plus 1 over tan squared theta minus 1 is identical to that. So let's use the left hand side. So tan squared theta plus 1 over tan squared theta minus 1 is the same as, for tan squared theta is as good as sine squared theta over cos squared theta, and it's plus 1. And the denominator, what we have at the bottom, is as good as sine squared theta over cos squared theta minus 1. Now we are going to multiply by cos squared theta over cos squared theta. If we do, multiplying cos squared theta by this top fraction, we will be left with sine squared theta plus cos squared theta, and at the bottom, if we multiply by cos squared theta, we'll be having sine squared theta minus cos squared theta. Now the top part will give us 1, and the bottom part, in order for it to come to be 1 minus 2 cos squared theta, I'll say sine squared theta is 1 minus cos squared theta, and that's minus the cos squared theta that's already there. So basically we'll be having 1 over 1 minus 2 cos squared theta, and that's what they want us to show right above. So I'll say hence proved. Let's go on to the next part. They say, using the results of A and B, solve this equation for values of theta between 0 and 180. Right, so this left hand side is what we proved to be this. All right, so that means here that the equation can stand to be this equals to 4 cos theta, and if we multiply both sides by the denominator, we get 1 being equal to 4 cos theta of 1 minus 2 cos squared theta, like this, which is 1 is equal to 4 cos theta minus 8 cos cubed theta. And if we take everything to one side, that's like 8 cos cubed theta minus 4 cos theta plus 1 equal to 0. All right. Now I want you to consider this and let x be equal to cos theta, which means this will be 8x cubed minus 4x plus 1, which we know from part A, we had gotten that it's identical to the 8x cubed minus 4x plus 1 is identical to this, the 2x minus 1 of this. So let me just copy this. All right, so it's basically the same as this, which therefore, if we take back the cos theta, it will be 2 cos theta minus 1 of 4 cos squared theta plus 2 cos theta minus 1. And since we had said this thing is equal to 0, this thing again will be equal to 0. So it's either 2 cos theta minus 1 is 0, or 4 cos squared theta plus 2 cos theta minus 1 is the one that's equal to 0. So here we get cos theta to be a half. So here we can try to solve this using the quadratic formula. All right, so cos theta should be equal to, and I'm just going to use the calculator for convenience. So basically here I'll go to equation mode. So 5 and quadratic is 3, and the coefficient of the square term is 4. So 4 equals, and 2 equals, and minus 1, and it's equals, and the answers are 0.309. So 0.309, and the other one should be minus 0.809. So minus 0.809. So these are the values we have. Now we know that the values we are looking for are between 0 and 180. And for cos theta being a half, if we say theta is arc cos of a half, we know that arc cos of a half is 60 degrees, and 60 degrees is between 0 and 180 degrees, so it's a good answer. The other value, we know that cos is positive in the fourth quadrant, and the value is beyond 180, so we will only take this value here for theta here, and here we'll be having theta being arc cos of 0.309, and theta being arc cos of minus 0.809. Here, arc cos of 0.309 will get a first quadrant value which is between 0 and 180. So I'll just simply go to say shift. Okay, let me make sure that we are in degrees. Alright, so option 3. So shift cos 0.309, and this will give us 72 degrees. That's a first quadrant value, so 72.0 degrees. This is a good value, and since cos is also positive in the fourth quadrant, the other value of theta will be beyond 180, so this should be an okay value. The last one is this one here. Arc cos of this, we get 143.99, which is 144. So I have 144 degrees here, which also I'll take as the only value which qualifies for the range 0 to 180. All right, let's move on. So that's how we do it for this question. Let's move on to number 8. On number 8, the question says, functions f and g are defined by f of x is equal to x plus a squared minus a for x is less than or equal to minus a, and g of x is equal to 2x minus 1 for x is an element of all real numbers, where a is a positive constant. So on part A, find an expression for f inverse of x. All right, so here I'll let y be equal to x plus a squared minus a, and I'll interchange the variables. So x is equal to y plus a squared minus a. I'll make y the subject, so x plus a is equal to y plus a squared. Square root both sides, so plus or minus the square root of x plus a is equal to y plus a. So basically we'll be having y being equal to, if we subtract a from both sides, minus a plus or minus the square root of x plus a. So this is what we have. But if you look at the domain, it's x is less than negative a, and we know that the domain of a function tells us what the range of the inverse function is. So basically, if x is less than or minus a, we know that for our f inverse of x, it can only be less than minus a if we have a negative sign here. All right, minus a minus root of x plus a will give us a range that is less than or equal to minus a. So basically, the answer will be minus a minus the square root of x plus a. So this is what we get right here. Let's move on to the next question, and that's part B. It says we should state the domain of f inverse. Okay, we should state the domain of f inverse. All right, so basically you should know that the range of your original function gives you the domain of your inverse function. All right, so when we talk of the range of the original function was such that it was, if we are to consider the graph, we know that it's a U-shaped parabola with the minimum point at minus a and minus a. All right, I'm taking it from the completed square form, and it is defined only for x is less than or equal to a. So it is only defined for this particular region, and not this other part is not required. So let me just remove it. So this is what we have right here. Okay, and the range are the set of y values. So from the minimum point going up all the way to infinity, that is the range of the original function. So the range is values of y that are greater than or equal to minus a. So this is the range of the original function, and this also gives us the domain of the inverse function. So if the range is y is greater than or equal to minus a, the domain will be in terms of x, so x is greater than or equal to minus a. All right, let me write that in black. So that's how we do it. Next up, they say we should find the range of f inverse of x. All right, so for the range of f inverse, we say that it is the same or comparable with the domain of the original function. All right, and the domain of the original function was x is less than or equal to minus a. So basically it will be f inverse of x is less than or equal to minus a. So simply like that, and that's how we do it for this particular question. Let's go on to the next part, and that's part C. It says, given that a is equal to 7 over 2, solve the equation g of f of x equal to 0. Right. Now, the original information we have for question 8 is this information here. That's what they told us at the beginning of the question. And now they say g of x is equal to 0. So that's basically g of f of x. F of x is x plus a. So let me put another bracket. So it's x plus a squared minus a. So g of this is equal to 0. Now the function g is such that g of x is 2x minus 1. So basically 2 of x plus a squared minus a, all right, minus 1 is equal to 0. All right, so that's 2 of x plus a squared minus 2a minus 1 is equal to 0. All right, which means that 2 of x plus a squared is equal to 2a plus 1. All right, so let's continue simplifying this. So basically we have here, dividing both sides by 2, we have x plus a squared being equal to 2a plus 1 over 2. All right, and while we're here, let's consider the fact that a is equal to 7 over 2. So basically we are saying that x plus 7 over 2 squared is equal to 2 of 7 over 2 plus 1 over 2. So we could have substituted 7 over 2 early on, okay, but I've just done it at a later stage, which is still okay. All right, so basically we'll be having x plus 7 over 2 squared is equal to, this here will give us 8 over 2, so that's 4. All right, so square rooting both sides, we'll be having x plus 7 over 2 being equal to plus or minus 2. So x will be minus 7 over 2 plus or minus 2. All right, and the values of x will be minus 7 over 2 minus 2 or minus 7 over 2 plus 2. So x will come out as minus 7 over 2 minus 2 will be minus 11 over 2. and the other value, minus 7 over 2 plus 2, is minus 3 over 2. However, if you can look, we have been told that for f, x has to be less than or equal to minus a. Alright, so we are going to take the value that is less than minus a, and we can see that minus 3 over 2 is actually greater, so we will only have x to be minus 11 over 2. Alright, and that's since x has to be less than or equal to minus a. Alright, so this here becomes the final answer we get. Let's move on to the next question, and that's number 9. On number 9, they say the diagram shows curves with equations y is equal to 2x to the half plus 13 of x to the minus half, and y is equal to 3x to the minus a half plus 12. The curves intersect at points A and B. So on part A, find the coordinates of A and B. Alright, so basically we have two curves intersecting, and we can solve them simultaneously by equating them in this case. So we're saying that 3x to the minus of a half plus 12 is equal to 2x to the half plus 13 of x to the minus a half. Alright, so that's the equation we have, and let's try to simplify it. Alright, so if we take the 3x to the negative half to that other side, and the 12 again, we'll be having 0 here, and minus 12, and it's plus 2x to the half, and it's going to be plus 10x to the minus of a half if we subtract 3 from this one here. Alright, and basically this is 0 is equal to minus 12 plus 2x to the half, and it's plus 10 over x to the power of a half. So I am going to say let another letter like u be equal to x to the power of a half, which will give us 0 is equal to minus 12 plus 2u plus 10 over u. And if we multiply all the terms by u, we will be having right here 0 is equal to, and I'll start with the term in u squared. 2u times u is 2u squared, and this becomes minus 12u, and this becomes 10. So this is what we now have. Let's start by factoring out a 2, which would be u squared minus 6u plus 5, and that's 2 of u 5 1 minus minus. So this is what we're getting, which therefore means that either u minus 5 equal to 0 or u minus 1 equal to 0, where u is 5 and u is 1. Now u was x to the power of a half, therefore x to the power of a half is equal to 5, which leads us to having x being equal to 5 squared, which is 25, and x to the power of a half is equal to 1, which leads us to having x to be equal to 1 squared, which is 1. So these are the two possible values of x, and we can simply find the corresponding y values, all right, by saying xy here, and when we have x being a 1 or a 5, when x is a 1, what is y? When x is 1, that's 2 plus 13, so y will be 15, so 15 here. And when x is 25, this was supposed to be 25, sorry. When x is a value of 25, this will be, we can even use this second equation, y is equal to 3 over 5 and plus 12, which should give us 63 over 5. So basically, when x has a value of 25, y is 63 over 25. So the coordinates will be 1 and 15 and 25 and 63 over 25. So that's what we will be having. Those are the coordinates of A and B. So actually A is the one with the lower value of X and B is this other one. So we have B here, and that's how we do it. Let's go on to the next part, which says, hence find the area of the shaded region. All right, so they want us to find the area of the shaded region, and to find this area we'll need to find, okay, we know that this X value is a 1, and we also got B to have an X value of 25. So we will say area under the top curve minus area under the lower curve. All right, so for the top curve, the equation is like this. I mean the function y. So we will say the integral, okay, from 1 up to 25 of the top function. All right, so here is the function, and it's with respect to x, and minus the integral from 1 up to 25 of the function below. All right, which is this function here. I'll just copy the form of that function and I'll paste it here, and basically that's with respect to x. So that's what will give us the area. So integrating here, plus 1, that's a half. 3 divided by a half is 6, so we have x, 6x to the power of a half, plus 12x, and 1 up to 25 here, and integrating 2x to the power of a half. Half plus 1 is 3 over 2. 2 divided by 3 over 2 is 4 over 3, so we have 4 over 3 of x to the power 3 over 2. Then here, minus a half plus 1 is a half, and 13 divided by half is 26, so it's plus 26x to the power of a half, and the limits are 1 up to 25. So let's simplify what we got. So it's 6 of 25 to the power of a half plus 12 of 25 minus 6 minus 12 if we substitute 1, and that's going to be minus here. That's 4 over 3 of 25 to the 3 over 2, okay, and it's plus 26 of 25 to the power of a half, and it's minus 4 over 3 minus 26 if we substitute 1. Right, so basically this is 6 of 5 plus 12. Okay, so let me just do it like this. 6 times 5 is 30. 12 times 25 is 300, so plus 300 minus 6 minus 12 minus, and here we have 4 over 3 times square root of 25 is 5. 5 cubed is 125. 125 times 4 over 3 is minus 500 over 3, and then 26 times 5, that's 130, so it's minus 130. Then it's plus 4 over 3, and it's plus 26. All right, so basically we will need to simplify the thing that we have right here. So I'll just use my calculator. And here we get 128 over 3. So we have 128 over 3 units squared, and that's the answer right here to part B. And that's how we do it. All right, let's go on to the next question. That's question number 10. It says the equation of a curve is y is equal to f of x, where f of x is equal to 4x minus 3 to the 5 over 3 minus 20 over 3 of x. So on part A, find the x coordinates of the stationary points of the curve and determine their nature. Alright, so we're talking about stationary points, and we know that f prime of x should be equal to 0. So differentiating here, we'll be having, taking down the 5 over 3, then differentiating 4x minus 3, we get a 4. Then we have 4x minus 3 to the 5 over 3 minus 1, which becomes 2/3, and it's minus. Differentiating 20 over 3 of x is minus 20 over 3, and we equate this to 0. All right, so this is as good as 20 over 3 of 4x minus 3 to the power of 2/3, and it's equal to 20 over 3. Divide both sides by 20 over 3, so we'll be having 4x minus 3 to the 2/3 is equal to 1. So we'll cube both sides and square root both sides, so that we'll be having 4x minus 3 is equal to plus or minus 1. So 4, actually basically x will be 3 plus or minus 1 all over 4. So x will be having values of 3 minus 1 over 4, that's a half, and 3 plus 1, that's 4 over 4, or 1. So these are the x coordinates. All right, x is equal to a half and x is equal to 1. Let's go on to the next part of the question. It says on part B, actually still on part A, they say that we should also determine the nature. So we'll do the second derivative to determine the nature. Right, let me just underline the answers we had obtained right here. So let's go on to the finding the nature. So for the nature of the stationary points, we'll do the second derivative. Right, the first derivative, we had obtained it as this, 20 over 3 of 4x to the 2/3. So we still have the 20 over 3. We'll bring down the 2/3. Then the derivative of 4x minus 3, which is 4. Then the 4x minus 3. And 2/3 minus 1 is minus a third. Alright. And differentiating the constant, we get 0. So this will suffice for the second derivative. Alright. So basically, this will give us 20 times 2 times 4, which is 160. And 3 times 3, that's 9. Or 4x minus 3 to the power minus of a third. Alright, so when x is equal to a half, that's f double prime of a half. We substitute a half here. Alright, and if we do, that will be 2 minus 3 here, and raised to the power, to this power, we get a minus 1. So basically it's minus 160 over 9. And when x is equal to, here's a value of 1, that is f double prime of 1, that's here 4 minus 3, that's 1. So basically we get 160 over 9. So on top we are getting something that is less than 0, and therefore it's a maximum turning point, and something this is greater than 0, and therefore it's a minimum point. So that's how we do it right there. Let's move on to part B, where they say state the set of values for which the function is increasing. All right, so we have two turning points, one that is at x equals to a half and one that is at x equals to 1. All right, so, and we have obtained that the one at x equal to a half is a maximum. All right, which means that at a half, right, when x has a value of a half, okay, x is a half, since it's a maximum, it means that it's a stationary point, and for values less than a half, they have a positive gradient and a negative gradient, and a negative gradient for values that are greater than a half. All right, and we would say that the function is increasing for values of x that are less than a half, like that. And the other point is when x is equal to 1, and it's a minimum, so minimum means this, so it's increasing for values of x greater than 1 and decreasing for values of x less than 1. So values of x greater than 1, the function f is increasing. So I'll take this and this for our solution. Okay, let's move on to the very last question, which is number 11. It says the coordinates of points A, B, and C are 6, 4, P7, 14, 8 respectively, where P is a constant. The line AB is perpendicular to the line BC. So on part A, given that P is less than 10, find the value of P. Alright, so here we have 3 points, and the situation is like we have something like this, where A, B, and C are such that AB is perpendicular to BC, as we have been told. Alright, now A has coordinates from what we've been given, 6, 4, B is P7, and C is 14, 18. So since AB is perpendicular, okay, so it is perpendicular to BC, it means that the gradient of AB times the gradient of BC should give us -1. So the gradient of AB will have the gradient 7 minus 4, which is 3, over P minus 6, so P minus 6, times the gradient of BC. BC is 18 minus 7, which is 11, over 14 minus P, so 14 minus P, and that's all equal to -1. Alright, so 3 times 11, that's 33, is over P minus 6 of 14 minus P is equal to -1. So it's like P minus 6 of 14 minus P is equal to -33. Expanding the brackets, we'll be having P multiply this to give us 14P, this 2 to give us -84, this 2 to give us minus P squared, and this 2 to give us plus 6P equals to -33. Alright, and we'll be having minus P squared here, and 14P plus 16P is plus 20P, then -84 plus 33, if we take the -33 to the left, will give us minus of 51, and it's equal to 0. Dividing all the terms by -1, we get P squared minus 20P plus 51 equal to 0, and we can do this, P here, and 17 and 3 minus and minus, and we have factorized it, which therefore means that the values of P are 17 or 3. But the question says that P is less than 10. So I'll say here, since P should be less than 10, P therefore should be equal to 3. We'll pick the value 3 for P instead. Alright, so that's what we will be having. Let's move on to B, which says that a circle passes through the points A, B, and C. Find the equation of the circle. So using the diagram which we have already, right, I'll just copy it and I'll paste it down here. Right, so this is the diagram we are going to use, which looks good. All right, so they say that a circle passes through these 3 points, right? Might not be the best diagram, but okay, let's just say it's a proper circle. Okay, let's just say this is a proper circle, and it's a circle that passes through all the points, and we have a right angled triangle here, and using circle geometry, AC should therefore be the diameter, so that the semicircle here, the semicircle AC, will subtend a right angle to the circumference. All right, angles subtended by a semicircle to the circumference are right angles. So AC is the diameter, and that helps us in finding the equation of the circle, because the center of the circle is the midpoint of AC. equals to midpoint of AC, and that's adding the x coordinates, that's 6 plus 14 over 2, and the y coordinates 4 plus 18 over 2. 20 over 2 is 10, and 22 over 2 is 11. So the center is 10, 11. So we have 10 and 11. So for the radius, we can simply say radius is equal to the square root, and that's the square root of, and here we'll be saying 10 minus 6 squared plus 11 minus 4 squared, which is the square root of, okay, here that's the square root of 4 squared plus 7 squared, all right, and that's the square root of 65 basically. All right, so the equation of the circle, will be x minus 10 squared plus y minus 11 squared is equal to root 65 squared, which is 65, and that's how we do it for that particular question. Right, let's go on to the last part, which is part C. It says find the equation of the tangent to the circle at C in that form. All right, so we still have the diagram here. I'll copy it and I'll paste it down here. All right, so we have the diagram right over here, and it should be good. All right, so they say that there is a tangent at C. All right, so that's a tangent, and they want us to find the equation of that tangent. Now we know that the tangent will make a right angle with the radius or with the diameter. All right, so if we find the gradient of AC, it will help, which is 18 minus 4 over 14 minus 6, which is 14 over 8, okay, and that's the same as 7 over 4, right? So that's the gradient of AC. So gradient then of tangent at C will be minus 4 over 7, which is the negative reciprocal. All right, and it passes through the point 14, 18. So therefore, the equation of tangent should be equal to y minus 18 is equal to minus 4 over 7 of x minus 14. All right, so that's like y is equal to minus 4 over 7 of x, and 14 times 4 is 56, so it's plus 56 over 7, and it's plus 18. All right, and we're going to multiply all of them by 7, so by 7, by 7, by 7, by 7, so we'll be having 7y is equal to minus 4x plus 56 plus 18 times 7 is 126, and 56 plus 126 is 182. So if we take everything to one side, we'll be having 4x plus 7y, and that's minus 182 and equal to 0. And that's the answer we get right here. And that's actually the last question on this paper. And thanks for watching.